Here is a question from JEST 2012. The topic is Special Theory of Relativity and subtopic is relativistically invariant quantities. Let us recall relativistically invariant quantities and then we will come back to this problem. So there are some quantities which are relativistically invariant quantities, which are also called Lorentz invariants. These quantities have the same value with respect to all inertial frame of references. So one example is speed of light. C is same in all inertial frames of references. Charge Q is same in all inertial frame of references. E dot B, the value of E dot B will be same in all inertial frames of references. X square plus Y square plus Z square minus C square T square will be same in all the inertial frames of references. Therefore, these are Lorentz invariants. Another one is magnitude of electric field squared minus C square times magnitude of magnetic field squared. This is invariant. E square minus P square C square. Here E is not electric field, this is energy, and P is momentum. So E square minus P square C square, this is another relativistically invariant quantity. So there is a list of quantities which does not change its value with respect to different inertial frames. In all the inertial frames, their values will be same. One of them is E dot B. Now it is given that in this question there is a point P. So we are viewing from S frame. There is a frame S frame. In S frame there is a point P. At point P, E is equal to 0 in S frame, but B is not equal to 0. Magnetic field is not equal to 0, but electric field vanishes. Now we are asked the relation which will be satisfied in any other inertial frame. So if E is equal to 0, then that means E dot B is equal to 0. And E dot B is a Lorentz invariant, which means E dot B will be 0 in any other inertial frame of references. Therefore, option B is the correct answer here.